In this question, we're going to explain the concept of two parallel planes. Alright, and using that concept to finding the equation of a plane that given a point, and they said that the plane is parallel to another plane. So what is the meaning of two parallel plane, right? So it means that the easiest to explain will be the two plane is having the two parallel normal. For example, you have a plane, right? And this plane is having the n1, the normal vector. Actually, the normal of the plane is define the direction of the plane. Okay, let's say there is another plane, right? There is another plane with normal n2, right? So these two planes are parallel, or we can say that n1, you can take n1 as the normal of this plane, or you can take n2 as the normal of this plane, right? Because this plane have the same direction, all right? Having the same direction, or we say that not same direction, they are parallel, all right? We actually say that n1 is parallel to n2, or we can write that n1 is a scalar product of it's a scalar multiple of n2, right? The vector n2. Then this show that these two plane is actually parallel, alright? Or we can just take n2 as n1 or n1 as n2, or n1 is a multiple of n2 or n2 is a multiple of vector n1. So this is called parallel. So I show you that if I have two paper, alright, I have a two plane. Let's say I'm having a two plane, right? This plane and this plane, right? I'm having two plane, so this plane and this plane. These two planes having the same direction because the normal facing, right, in the same direction as the normal for this plane also facing above. So these two planes is actually parallel. So they are parallel, right? They're moving towards here or moving towards there. But if you see that this plane and this plane, right? This plane now, these two planes, they are no longer, one is facing there. One is facing up, one is facing inwards, one is facing upwards. So these two planes is not parallel, alright? Because the normal of the plane are not parallel. So this is the concept of parallel. So, but for this question is slightly different. It's because they're telling that find the vector equation of the plane that contain the point, right? You already have the point, but the problem here is you need to know the normal of the plane. As the equation of plane, the formula is r dot n equals to a dot n. You have the value of a, which is 2, -1, 3. But you don't have the value of normal. So it's again, you have to find the normal. So I'm going to explain what is meant by parallel to the xy plane. Alright, okay, let's listen to what is the xy plane. So if you know that in 3 dimensions, we have a coordinate axis of x, y, and z, right? X, y, and z. And the z axis is always perpendicular to the both of the axis. It's always perpendicular. The z is always perpendicular to x and also y. Alright? Means that z is a normal vector for xy plane, right? Xy plane. And the same thing here. If I can say that y is perpendicular to z axis and also perpendicular to the x axis, right? It's perpendicular to x and z axis. So as I can say that y is the normal vector of xz plane. This is called xz plane, right? Just like Cartesian plane, you know that xy plane, right? Xy plane. So then the xy plane, the normal of the xy plane will be the z-axis, right? Or the unit vector z, okay? So unit vector represent z-axis. So, and y will be the normal vector, the y-axis will be the normal, right? A line normal to xz plane. And whereas x-axis is perpendicular to z-axis and also perpendicular to y-axis. So it means that x-axis is the normal of zy plane or yz plane. So for these cases here, so they said that find the equation of the plane containing the point, right? Okay, and is parallel to the plane. So when I said parallel here means that we can take the normal of xy plane, right, as the normal of this plane, right? So for example, these two planes are parallel, right? Plane 1 and plane 2 are parallel. We can actually directly take n2 to be n1 and n1 to be n2, as these two are actually parallel, right? So now for these cases here, we're going to find the normal of xy plane. The normal for xy plane, a perpendicular will be z-axis. We will usually denote the normal for this xy plane with k. K, because k is the unit vector for z-axis. Alright, so very simple. So now we have already know that normal is k. So k here means that the normal vector is 0, 0, 0, 1. Alright, for z, 1 unit, the unit vector. So I'm going to substitute here with 0, 0, 1. Right? So when I calculate, I have r dot n, right? R dot n, which your n is a k, right? N is k. So it's calculate 2 times 0, 0, 0, 3 times 1, you have 3, right? Means that r dot k is 3. So this is a vector equation, right? It's a vector equation of the plane. So if you want to find the Cartesian equation, very simple, as k represents z. So I can straight that way, right? The Cartesian of the plane will be z equals to 3. So what is z equals to 3? Right? What is z equals to 3? Z equals to 3 is a plane. Let's say you have a tree. You have 3, okay, on the plane. So at here, I have a plane that above, I have a plane above the xy plane here. Can you see that? It's very hardly to draw the 3 dimension. So z equals to 3 is a plane. It's a plane that intercepts the z-axis at 3. Or it's a horizontal plane. And this plane has a normal vector k. And the xy plane also have a normal vector k. So, but the plane z equals to 3 is higher compared to the xy plane. Another name for xy plane is z equals to 0. Okay, this is an extra knowledge for you, right, that I'm going to explain, but this is your answer, right? If you love mathematics, you will understand. So z equals to 3 is above the xy plane. For any point on the xy plane, the coordinates, the z will be 0. Alright, so this is they have a parallel, right, as is above this plane, but they actually have the same normal vector. So, okay, let's say, what if the question asking for xz plane, right? Alright, now I'm just changing the question. Let's say become xz plane, right? So I redraw. So we have x, y, and z, right? So for xz plane, this plane, right? The normal will be the j, the y-axis, right? The unit vector. The unit vector. It can be 2j, negative j, any, as long as it's j, right? It's in the direction of y-axis, right? It's parallel to y-axis. So now it means that n can be rewrite to be 0, 1, 0, right? For the y, x, y, z. So then here you will have 0, 1, 0. And if you calculate, you will have r dot n, okay? R dot j. So your vector equation, r dot j will be the same as -1, right? -1. Or we say that y equals to -1. Y equals to -1 in 3 dimension is 2 dimension is different. So y equals to -1 in 2 dimension is a straight line, right? It's a straight line. It's a straight line that passing through y equals to -1, right? -1. So here is positive. So -1 is somewhere around here. So it's a straight line, right? But when you view from a 3 dimension, it's actually a plane. It's a plane. It's a plane that parallel to the exact plane, right? So it's hardly to draw. So this is an exact plane. It will be on the -1. So this plane is parallel to the exact plane, which have sharing the same normal vector, right? So if the question asking for YZ plane, right? YZ plane. So the normal will be the x-axis, which is 1, 0, 0 or I, right? Then then you will have x equals to 2 in your answer. So very simple. So when they said that parallel to a plane, right, then we take the normal of that plane as the normal for this plane that passing through this point. Right? I think that's all for this video, and going for more example in the next video about equation of plane.